this session is going to be on data exploration and visualization with Elasticsearch and Kibana. It's going to be a fairly high-level overview session. The issue with a conference like this is that you get all sorts of people coming. How many of you are data scientists or would self-describe as such? Okay, that's a relatively small part of the audience. Good. How many of you are engineering management or senior management, like director level? Okay, excellent. Developers as programmers? Okay, quite a few of you. All right, interesting. So how many of you have worked with a Jupyter notebook before? Aha. Okay, all right. I will shorten that part for you then. So the basic premise of what I'm going to tell you today is that we've got Jupyter Notebooks, which is a particular tool that's used by data scientists, but we at this company, and I'll tell you about the company, are wondering about expanding the abilities of data scientists and expanding the scale that they can work at using the open source tooling that we produce. And I should say our stack is not yet positioned specifically for data scientists, so I am here as part of an initiative to try to learn more about the needs of that community, and as part of gathering feedback to try to guide our product development so that we can in fact serve you better. But first, let me tell you about what we do already a little bit. So my name is Emanuil, and I'm a community engineer for Elastic, and that's Elastic. Elastic is a search company. Elastic makes the Elastic Stack, which is a set of tools, open source with some parts which are completely free to use, but not open source, and some parts which are commercial. Today we're only going to be talking about free things. I will, if I do show something that you need to pay for in order to use, I'll very clearly say so. So, what is the stack and why might it be relevant to data scientists? So first off, we start off with the heart of it, that's Elasticsearch. How many of you have even heard of Elasticsearch? Okay, right, the vast majority, great, okay. So it's for the ones that haven't heard, it's a distributed search engine. It's something that you can run yourself or you can run in cloud. And it's something that you throw JSON documents at, and you can very quickly search them. It's very good at full text search. It's very good at numbers and being used as a time series database and general analytics engine. So as you can see, we're starting to get a bit into data science territory in the sense that it can hold various types of data that data scientists be able to analyze. Now, Kibana is the graphical user interface to the stack. So typically, our use cases so far, meaning the way we make money to support the open source, has been mostly what these solutions are connected to. They're not the only tools we make, but they're at the heart of what we do. So Logstash, Beats, then APM, and a few other tools have to do with collecting metrics for the web performance of websites, and the logging produced by the various systems that we run in production. So this is typically has been in the field of operations, sysadmins, web developers, and so on. And so people store all of this diagnostic information, and then they are able to visualize it, to search it very quickly, including over very large volumes of data, and also have the ability to scale. And that's something that we're going to come to again. So with Elasticsearch, one of the things that sets it apart from other data stores, so well, they all try to be able to scale, but Elasticsearch has a particularly good approach to it and its own unique approach, and that's it shards the data as it's coming in. It's broken up into shards. So each database, if you imagine, is broken up into pieces and distributed among various servers, and you can add more servers very easily, and as you do so, the shards, so the pieces, are redistributed and moved on your behalf, and you can keep querying the data as this is happening. So to you, this is completely transparent. The thing has been very well battle tested for a number of years now. Project existed for about 8 years, and it's become from a 4-person open source project to a public company as of about 1 year ago. So it's been used very heavily in this web performance area, but since that also has to do with the analysis of data, even if it is web performance data, we've been thinking, or some of us in Elastic have been thinking, that it must be possible to use our tooling for the purposes of data science. So, common tools for data scientists. I'm not going to go too deep into that, since it's well, some of you were data scientists, some of you are developers, so maybe it is a good idea. So data scientists, first off, I'm not a data scientist. I come from a sysadmin background and a developer background and a small business background, so that means accounting, employment, and all other sorts of things. But I'm primarily a web developer. But I have a lot of data science friends, and I'm really interested in developing this area. So I've learned that data scientists use quite a lot of tools, but some of the common ones are Python, R, and Julia in terms of programming languages, and these are all runnable on something called Jupyter Notebooks, and you said that a lot of you had seen Jupyter Notebooks. There are also certain libraries used. My specialty is Python, so that's what I mostly focus on. In Python, you got libraries like pandas, numpy, scipy, scikit-learn. In general, these are tools that allow you to hold a large volume of data in as efficient way as possible, slice it up, move data from one column to another, merge columns, do data manipulation operations really quickly and efficiently. So, having said that, how big is a Jupyter notebook? It's kind of a strange question, but this is what got us thinking, specifically in the machine learning team at Elastic. And there isn't really an answer to this question, because how big is a notebook? Well, however, how much data are you going to put in it? What kind of computer are you going to run it on? That's how big it is. The concept of size in a Jupyter notebook is just defined by by the data contained within it and the code contained within it and the operations it performs. However, we can say that there is a certain limit. Like, for example, as I was trying to prepare a specific demo to use here, I hit a limitation. My laptop crashed. So we're not going to be seeing that demo. We're going to be seeing other demos. So there is a limitation, and that's the machine that you're running it on. And it's difficult to take a Jupyter notebook, relatively difficult to take a Jupyter notebook, and we're going to actually look at one, and scale it out and be able to run the same operations that you run on your own machine, be able to run them across many different machines. There do exist tools for distributed computation and distributed workloads, but going from a notebook to those tools is not straightforward. And we're wondering, can we make this more straightforward with Elasticsearch? So, if we take a quick look at one notebook. Okay, so this is a typical example of some data analysis that's being done. We're analyzing the Airbnb listings. So Airbnb actually posts these datasets as a dataset source, which I'll include a modified version of the slides, which I'll send to the conference, so you'll be able to download them. So here we can see a pretty typical way of analyzing this. We start with matplotlib. So this is important. This is the data visualization library that's used pretty commonly in notebooks like this. We do a bunch of imports. This is essentially just formatting. Okay, now we come to the interesting part. So here it's, for those of you who said that you are developers, but not the data scientists perhaps, it's important to realize the difference between the workflow of a developer and the workflow of a data scientist. A developer, like me, typically focuses on producing an artifact, a piece of software at the end of their development process, and maybe a process to maintain that software, and perhaps a team that you maintain it with. So there are playbooks to write that help you maintain this. There's all those sorts of outputs that you have, deployment scripts, all kinds of things. So far from what I've seen from data science workflows, data analysis, that particular part of data science, focuses on the creation of a story and on the encapsulation of the process itself. So the artifact of data science is not a piece of software, it's the process. You glue different tools together, much like in software, in order to produce a story. So you start with specific tooling, with specific versions of that tooling, and then you record that process. So this is essentially an interactive lab notebook. And you did say that most of you have seen that, so we're going to zoom through most of that. So what we've done here is we've loaded the file with the Airbnb listings. Actually, I can just look at my own screen. With the Airbnb listings. And here we've done a little piece of data exploration. So here we've seen, here we're asking for the top 5 records in the data set. And we'll see how that, how you'd be able to do this in in the Elastic Stack. And we do some cleaning and pre-processing. So here we do things like, there's sometimes dirty data, so for example, words in the price field and things like that, so we don't want that. So we just go through that and clean it up, and here we are. So we have 24,000, hopefully clean listings by this point, and we have 15,000 hosts, so there's quite a few entry-level landlords in there. Right, so here we do a further bit of data analysis, well, of data grouping, I would say, or data cleanup. So we want to focus only on apartment listings rather than where you have shared bedrooms. And here we've narrowed down that data set. And now here we get to an interesting part. We are going to group by the property type and see, now that we've removed the shared rooms, what do we have left? So here, this is really the first part where we start to understand what our data actually looks like. And I'm assuming the front rows can see that, the back ones probably not so much. But anyway, this middle bit here says house, and that one over there says apartment. So we're starting to get some idea of the shape of the data. Okay, so what we're looking at is nearly 10,000 apartments, and then second after that, we got about 3,000 houses. Now, following that, we might want to do some aggregations, and that's actually an Elasticsearch term, so we might want to do some further grouping. Some stats. Oh, wrong key. Right, okay. So we have a number of unique cities in there, so we're looking at these about 15,000 records, and we want to extract from them how many cities there are, and how many neighborhoods, and how many streets. So, and this we do by using the pandas library. We want the city column, and we want the number of, I didn't touch that, so I'm not sure what's going on. We want the number of unique columns in there. So this is how you would do it in Jupyter with pandas and matplotlib. And then there's other things we can do. Here we've asked for another aggregation with a group by. So we've asked for the average price per neighborhood. And we do that this way. So we ask for the mean from the price field, and we plot a bar chart. Okay, right. So the question, of course, is what does this have to do with Elastic? And why am I showing you this? So imagine that you had a data set not just for Melbourne and not just for Airbnb, but all dwellings that currently exist on the surface of the planet, and that you had some metadata about each person. So you have about, 7 billion people on the planet. I don't know what the average number of dwellings would be, but it would be quite a lot. If you held the same amount of metadata that this holds about each dwelling, then you would exceed the abilities of this laptop to handle that. And indeed, when I tried to do something like that, because I want to show you it in the Elastic Stack, it worked to some degree at home, and it stopped working about 15 minutes after I got here. That's how it goes. Now, however, we can still imagine it. So imagine that you had that much data, right? The problem is still obvious. You can't use a Jupyter notebook to analyze it and visualize it, right? You have Python core, a Python kernel running on this, so the Python programming language. You have all these libraries, and that's wonderful, and it works very well for starting to have a look at the data, but when it's much larger, we have a problem. So, right, which is where we get to my point. Okay, since I couldn't give you the dwelling data, instead, I'm going to show you what you can do with flight data. So these are flight records. This is a dashboard. This is the Kibana UI tool. How many of you have used Kibana before? Okay. Okay, less than half of you. Okay, so this is probably useful for you to see. This dashboard is not predefined, like we are not a specific dashboard vendor for flight data. This is something that you can build. The tool itself allows you to define visualizations and build them, and you can add summaries as well. So Elasticsearch itself has the ability to run aggregations and queries, and that gives you the ability to ask for things like averages, totals, means, all sorts of analysis. And then you can define them like this. So what does that look like to begin with, right? So this is the end result. But when you come in, right, you are not going to actually see that. You are going to see something akin to the 5 top records that I showed you in the Jupyter notebook. And the equivalent in Kibana is this. So this is how your data will be coming in. That's the wrong index. That was logging data. There we are. These are the flights. Okay, and so this is very similar to what you would see in Jupyter with the top 5 records, but instead of just being held in the memory of my machine, this is held in a cluster, and you can have extremely large amounts of memory. I mean, you can have terabytes of memory dedicated to this particular task. And you can search this really quickly. So for example, if I wanted to know, does Beijing feature in the data at all? And I mean, you can do very complicated things here. You can search for specific fields, you can visualize specific fields, you can visualize correlations, and do all sorts of things. We can see that it does feature. So the next step, the next thing you would do is you would go to Visual Builder, and you would select a particular visualization, and you can, I'm not going to go through all this now, don't worry, and you can select like pie chart, bar chart, etc., and you can put these, thank you, you can put these together on a dashboard like the one I showed you. Okay, well, we've already seen the general flight data. I have various examples of this. So the Elastic Stack is capable of visualizing a huge range of data. We have geo, we have graph visualizations, our maps, we have our own, we have like a tile service offering. So there's all of that too. And all of this is completely free to use. So there's no limit, it's not a trial. There are no commercial limits. You can use it if you're a huge corporation. It doesn't matter to us. You can just download it, install it, use it yourselves on premise, or use it in cloud. We have a cloud offering, and there exist other alternatives to our cloud offering as well. So in general, you can do quite a lot. Now, what else can you do? I mean, okay, but so far we've seen Jupyter and we've seen this, and even though I couldn't show an exact correlation between the one data set and the other for demo gods reasons. Nonetheless, you get the point, right? We go from something that's limited to this to something that's been quite well tested for analysis of web performance data and many other kinds of data, but is not well known, as far as I understand from my data science friends, not well known in the data science community. The tooling is, I mean, it's a point and click. It's relatively straightforward to use, with the one exception which we are working on, which is your ability to get your data into Elastic. And at the moment, this is how you would get your data into Elasticsearch. And so if any of you are willing to stay after and chat, I'd be really curious if you have used Elasticsearch, either as a data scientist or as a developer, especially as data scientist, I'd be curious to know whether you understand this and whether this seems intuitive to you at all. Because to me, this seems pretty intuitive, but I've been an Elasticsearch user for 5 or 6 years, and I have given to understand by data scientist people that this is not very intuitive to them at all. So this creates a connection to Elasticsearch and uploads all of your data from the notebook into Elasticsearch so that you can make that connection, that you can go from one to the other. Now, beyond that, beyond the, we go from Jupyter to Elasticsearch, we can scale now, we can just add servers, we can run this on-premise, run this on cloud, fine, and it has a visualization tool, we can use it, great. You showed this, I guess, more commercially, it may matter to you because you got relationships with your business stakeholders, so you probably want to show them results more quickly, and it's a bit difficult to go directly from a Jupyter notebook to something that's hosted that you can share with the rest of the business, especially if you're a remote team. And it can be difficult to keep those results up to date and real time. So that's another reason to try to put your data into Elasticsearch, play with Kibana and see what happens. But this is a commercial tool, so this is something paid that we make. The reason I'm showing you this is because I think it's an interesting capability. So this is an example of unsupervised learning. So you give this some data, minimum 2 weeks, I believe, and it will construct a model. Model bounds are not available for this. So it will construct a model as well as a confidence interval for that model from the data, and it will try to understand what is a normal reading and what is a potentially anomalous reading, as you can see the yellow dot here, and what is a totally anomalous reading. And you don't have to label the data, that the data scientists among you will note that that's the unique capability that it has. Now, the reason that we're selling this at all is because it's useful to people who deal with their performance data, right? To them, it matters that they don't have to say exactly when is something slow, like how long is a piece of string. You got that same problem again, right? They don't want to say, well, half a second is slow, because in one situation, if it's financial transaction, half a second may be way too slow. In a different situation, this may be very, very quick and very much within bounds. But so it learns what is slow and what is quick based on the data that you give it, and it learns the context of that. Well, it learns by the numbers at least. It's not general intelligence. Now, the interesting thing for me, and the reason I'm showing you this, is because I understand that data scientists train their own models quite a lot. Thank you. Like with scikit-learn. Now, we are thinking of enabling people to run custom models on Elasticsearch data. The same as you would train in scikit-learn, that have the ability to run your own model. And we're not yet clear on what the limitations of that would be and how we should shape this development and how we should push it forward. But that's one thing that I'd be very curious to chat to the data scientists among you about, because I assume that the ability to run your own custom models on data that the RAM scales to a few terabytes, if you have the money to run the hardware, is probably quite interesting. And so I will say here that the translation from Jupyter to Elasticsearch is not always very clean, right? In Jupyter, specifically in Python and then especially in R, you have statistical methods that Elasticsearch does not have. But we are working on adding some statistical methods to it. So this is all about kind of the future and where we want to go with this, and whether this can be a useful tool to data scientists. I think its scale and its ability to easily process large amounts of data, its ability, its operability, like how easy it is to put it in production and to then maintain it, are huge advantages. And I think that there's a lot more to it than the way data scientists tend to see it, which is that it's a piece of software that their ops people run, and they have to learn some weird query language with lots of brackets to use. So there's not a one-to-one mapping between the statistical methods available in Python and in here, but we are trying to produce tooling that abstracts that for you. So actually, some of the statistical methods available are in fact translated. So you use this from within the Jupyter notebook, but instead of it being backed by pandas, it's backed by an Elasticsearch datastore. So you are able to access your data with the same methods you already know. You don't have to learn a new library, but the entire backend is Elasticsearch. Of course, the operations take longer since you have a round trip to the cluster, but you can access far, far more data and you can scale far more easily than a notebook on one machine. Right, so I think I've got a few minutes left, but I want to actually pause this here because I'm interested in your thoughts, what you saw of this tool, and if you did not know about it before, or if you hadn't thought of using it for data science before, do you find it interesting? Like, could you imagine yourself using it for your work, where you analyze data? And do we have a mic, actually? Right. Anyway, data scientists, you have, okay, we got one there. Yeah. There. So I know audience interaction is not very common at these big conferences.
Historically, we've used Elasticsearch for unstructured data, but as a data scientist, I tend to find myself using relational data significantly more often. Okay. In terms of importing data to Elasticsearch, how easy is it working with relational and like unstructured NoSQL data?
So with relational data, this is its primary use case, actually. So you can put unstructured logging data in it, like text files, but in terms of the search use case, like a product shop, for example, like Marks & Spencer's uses us for the search. When you go and you search on markspencers.com, that's what turns up. That data is stored in a relational database, and so there's a well-established pathway for that. You actually use Logstash currently, one of the projects that was on the screen. And you write queries that specify, from the tables, how do you go to an index in Elasticsearch? So it's well established. You got one?
I can see two questions. Well, basically for you. For big corporations, there's two things. So there's the confidentiality of data.
Yep.
So I don't know Elasticsearch at all. So I don't know, how it is easy to load some data that is confidential and cannot be seen outside the company. And the other question that I have for you is, how would you do it if data scientists that don't want to re-implement their models into a language of yours? Because implementing a model is really hard. Once you have it done in one language, you don't want to redo it again in some other language, because it's just really bloody hard to make it work once. So that's two questions for you.
Sure. So on the privacy question, that was an issue from the beginning. It's an issue with any data store, and so that's why you can take and run the open source project yourself. And we actually have, like for big companies, we have the commercial packages where you also take and run it yourself, but you get support and it's all packaged up for you. So you kind of do that, and it runs an instance of our own cloud plane, control plane, but you control it, not us. And it runs entirely on your infrastructure. That's Elastic Cloud Enterprise, I believe. I don't deal very much with these products, but yeah, so that's that one. The other one, that's a good question. So our machine learning team that implemented these things, they have, so their models are written in C, C++ in particular. And so they have a data team which produced the notebooks, and actually, the training. So the data team will go and train a model in Jupyter, and then they will try to learn from that, and they will write, the rest of the team will write some C++ code to modify the unsupervised learning model. That's, we don't have it figured out yet how you can port the models. We have already an attempt to port the analytical methods So like, say you wanted to run an average or even ANOVA, right? ANOVA we don't support yet, but obviously an average or a sum and all of these normal numerical methods we do support. And so we already have this so that you run the same command, like when you say your pandas .unique or .average or whatever on a given column. We already have a library, it's in alpha and it's not published yet, but we have a library which does this, but uses Elasticsearch as the backend. So I'm hoping that we would be able to provide something like this for the models, but it's very far off. But that's a good data point, that you would like that. That's good to know. Yeah. Anyone else? And I think, here.
Hi. Do you have any tools or something in the pipeline to essentially make part of that dashboard interactive for the user? So the user may, for example, if it's presenting a table, you want to like add a comment or add another label on that table, and then that rewrites to the data structure.
Yes, funny you should ask. Yeah, there is an issue in Kibana open for annotations and collaboration. So far, it's been a tool that's been aimed at web performance people, and so this hasn't been a very high priority. But if we encounter communities that would benefit from this, where we think it's useful to add the feature in general, then yes. And so there is, but I couldn't tell you when, but yes, it is something that we think about, yes. How are we doing for time? We need to finish up. Yeah, okay, right. Unfortunately, we do need to finish up, but can we talk over there with people? Is that okay?
If you talk outside, because
outside.
We've got a lot of people waiting to come in for the next
session. Yeah, that's why I don't want to go that way. Okay, so whoever wants to have a chat, I really want to talk especially to the data scientists among you, and to anyone who's thinking of doing data science or is doing data analysis and wants to use Elastic for it. Come over here to the left of me, and we'll have a chat. And I do want to develop this tooling. I'm pushing for this use case internally, so the more feedback I can get, the better.